your grandparents decide to purchase for you a trust fund that you will get at retirement, and they're going to start off by putting $2,000 into this trust fund. You will not receive the money until you're 65. So you get the money into a trust fund when you were born of $2,000, where the age of the grandchild is 0, and you will be given the money finally when you're 65. They're going to put it into long-term investments. In the period between 1925 and 1991, common stocks in the U.S. stock market earned just about 10%. So what we're going to do is use the relatively simple model that the value of the fund will be $2,000 times 1.1 raised to the number of years that the money has been invested, or A times B to the X. We're using 1.1 because when the growth rate is 0.1 or 10%, the growth factor is 1.1. Amazingly, the $2,000 after 65 years turns into almost $1 million. If we look at a graph of this, we can see that the $2,000 ends up being almost $1 million. The problem is, for the first 20 years, we actually don't get very much information of the graph at all, because we can't distinguish between 2,000 and 13,000 because the scale is so big here. One of the things that we can do is use a logarithmic scale. If we right-click and format the axis and go to a logarithmic scale, under the Scale tab, checkbox Logarithmic Scale and say OK, two things happen. First of all, we can identify all of the points along the way. And second of all, the characteristic exponential growth curve, which is concave up, when the y-axis is a logarithmic scale, becomes linear.